How to solve a system of simultaneous equations? Well, if I write two equations and I want to find a couple x and y for which these two equalities are true, I'll call E1 the first equation, E2 the second. So geometrically, this means that this is the equation of a straight line, and this is another one, and you are looking for the coordinates of the point where the two lines cross each other. Anyway, I'll take one of the two equations, so I will choose E1 just because the number are smaller than in E2, so it looks simpler, but you can choose any of these. So I'll choose E1. And the problem with these equations is that you have two variables. You have x and you have y, and you don't know how to solve something with two unknowns. But I don't know either. There is no solution. In fact, with two unknowns, it's the coordinates of all the points on your line. So there is no solution, basically. So the problem is that you have two unknowns. So the idea is to get rid of one to have calculations with only one unknown. So I'll use this equation to express y as a function of x, which means here I write y like that. I'll call it, you can give it any name. I usually use a star, but you can give it any name. If I put this in E2, I will replace x by its value as a function of x, which means I will have only x in here and I can solve it. So in E2, why do I use E2? Because I already used E1 for this. So if I put it into E1, I will get something, a tautology, something like x is equal to x, something useless. So if I put that in E2, I'll get, sorry, I have to start from the beginning. It's 5x plus 4 times, I replace y with this. So I just replaced y with its value here. Then I expand this, and then I solve it like a regular linear equation. It has only one unknown. You know how to do that. Sorry. Plus 4 times 1/2, it's 2, minus 4 times 3/2, it's 6, is equal to 6. And you write your operation on both sides of your equality, so you can get all the x terms on the left and all the constants on the right. You can do it very fast if you know what you are doing. Then I divide everything by -1 and I get x is equal to -4. Right, so I have x. I did half of the job. Now I want to know the value of y. So I just put x in there. This value I got, this x value, I'll just put it here. So that's why I gave a name to this equation. In star, I'll get not an equal. I get y is equal to 1/2 minus 3/2 times the value of x, which is -4. And I get y is equal to 1/2 plus 6, which means y is equal to 13/2. And your solution is a couple, because it's a couple of coordinates, where x is equal to -4 and y is equal to 13/2. And it's done.